Hi everybody. Just wanted to give you a little introduction to socket programming. This is from chapter 29 of my book Java for Programmers. First question is, what do I need it for? A socket in general is a conduit for an unformatted sequence of bytes or a stream, so we can use it for internet interoperability protocol, remote method invocation, creating web pages, creating a web server, getting information from a web server, doing various kinds of what we'll just term network computing. So the socket enables us to transmit and receive bytes in a stream. We can do inter-process communication, and typically we're working in something called TCP/IP, which is a transmission control protocol on our internet protocol, or UDP/IP, which is user datagram protocol. Typically you use an IP address and some port to connect to some service that's in the server. The mechanism for TCP/IP is unicast, which means you have one transmitter and one receiver. And if you want to transmit in a broadcast fashion, you use multicast. And in order to do that, you need a multicast enabled router, and typically you keep the entire internet from getting flooded with your traffic by having a time to live, which indicates how many router hops your packet can go before it gets blocked. So most computers have many servers. Port 80 is typically used for web services, 7 for ping, 13 for time, 25 for mail, and you can go to Etsy services to see the ports in Unix. And here's the basic example. You put in a host name, you get the internet address from the string host name, then you go and you create a socket on a specific port. This case, port 80 is being used, and the socket is then used to create a input stream or an output stream. And here we're using the get output stream method and get input stream method, and you can write data to the output stream. Perhaps some string can be converted to bytes, and then you can get some sort of a reply using this read method, which will tell you how many bytes were read, and will read the bytes directly into the buffer called reply. Typically you can start with a fully qualified host name. You put the host name in, the port, and create a connection to the socket. When you write out bytes, if you want a new line, you have to formulate it specifically. Here is a character turn. Here's a new line character. If you want to read data, you may have to format it. So here we're using the data input stream. And here's someone who's trying to use port 25, which is probably for doing mail from some host. And we're going to create a socket. We'll create a data output stream for the socket and a data input stream from the socket. We'll write some email message to the output stream, and the email message is going to have SMTP protocol, which is hello, the host name, and a character turn. Mail from, that's a code, and it'll actually show the address in here. Receipt to, that's who gets the address. The data, which comes in later. Some subject line, and then some mail content, whatever that may be. And then a quit command. So your entire protocol involves hello, mail from, receipt to, subject, and then quit. The Post Office Protocol version 3, known as POP3, works in port 110 instead of port 25. And in this case, we use a slightly different mechanism for changing things such as the username and password, because it's a more secure mechanism. It's a non-open protocol. Whereas SMTP will respond to anything and from anyone, which often means it needs to be kept secure behind a firewall. A A simple server here is shown where we create what's known as a server socket. It comes in on some port number. We'll use port 1234. When the connection's made, we do an accept, and the left-hand side of the equal sign is returned. This is running in the main thread of execution, so it's only going to accept one connection. We'll get the output stream from that socket. Then what we'll do is get a data output stream, write some Unicode text like hi there, close the data output stream, close the socket, and bang, we're done. A simple server. Accepting only one connection is probably not a good idea. You probably want to be able to accept multiple connections from a single server. In order to do that, you may need to create some threads, but that's something which we can do a little bit later. Here's a client which creates a socket on port 1234, gets an input stream, reads the data from the input stream, takes it, converts it to a string, prints the data out, closes the data input stream, closes the socket, and then you're done. So this is based on a little infrastructure that's required, and the infrastructure includes the java.net inet address. So the inet address enables us to get information about hosts we want to connect to, and that kind of information is going to be the IP address, and we can get that by host name. So here we have a fully qualified domain name with a host name giving us an address. And the internet address in here is typically going to be something like 192.168.1.1 or something like this. And that's going to enable us to get our connection. So here we are using the inet address, and we're getting the local host, and now we can get the local host's IP address, and we can print it out. So that's a good example of how inet address works. And here's a thing called a resolver, which enables us to resolve an address and turn that into an IP address. Once we start with a name, we can get the IP address automatically using resolver.java, and we'll work with the arguments coming in, whatever they may be. And we have already seen an example of daytime services. Daytime services, in this case, are running on port 13. We're able to go out to port 13 with a Telnet client, which is built into many Unix systems and some Mac and Windows systems. And it outputs a string which shows us the time and date. And it's pretty easy to write a Java daytime client. And we've seen that before, where TCP/IP connections are made on port 13, and then we go and we retrieve the data. So daytime servers start off by having a thing called a socket, and what they're going to do is they are going to get the time from some time-based host. They'll use the daytime port, which is port 13. We get an input stream. We get a string buffer. We do our read. We append it to a string, trim it out, and we can print it. And so it's pretty easy to create a daytime server using a server socket. And what that'll do is it'll open a TCP/IP port and wait for a connection. When you get the connection, the port is going to be created. It'll establish a connection to the client, push out the time, close the connection, and wait to accept another connection from some other client. And so here's the daytime server, which uses the inet address from the local host, creates a server socket, this time on port 0. You can make any port that's not occupied. Then what it does is it accepts a connection, prints out the connection information, then goes and gets the output stream, prints out the day to the output stream, and then closes the connection. We could probably run a little example on that for the daytime server. So here we go. We have a simple clock server, I'm going to run this on port 8085. What we're going to do in here is create a server socket, and we will accept a connection when someone comes in. Otherwise, this line is going to block the main thread of execution. When a browser comes in on port 8085 to the local host, it will launch the socket as an argument to the multi-threaded clock server. The multi-threaded clock server makes a new instance of runnable, but this can be replaced with a Lambda expression, and we can talk a little bit more about that later. The Lambda expression, that's an interesting side topic, and it's new in Java 8. So here we're going to go and do the clock server stuff, whatever it may be, and the clock server stuff runs as a separate thread once t.start is invoked. So here comes the clock server stuff, and what it does is it grabs a new date, gets the output stream. Let me format this nicely for television. Then takes the object output stream, writes it out, and then closes. Here's another version of the clock server stuff where we go and we get the output stream, and instead of writing it as a binary object, we make a string called Java util date, and now the clock server stuff is going to output a string, which we should be able to see. So this is the one that's going to be used in deference to the binary version. And what we'll do is give this a run, and now it says it's waiting to accept a connection on the port, and we will go to this connection and hit enter, and sure enough we're able to get the time. And so that's an indication that things are working properly. It's what port is this? 8085. 8085. There we go. If we went to port 8086, we'd see the serialized version of this, and it doesn't look quite right. There it is. So date and time, here you can see java.util.date is being passed as an instance, and that could be passed into a program that actually deserializes the java.util.date and uses it as a first-class object. That would come into an object input stream, and that would return an instance of an object when you did the read object. So that's my little demo of how to do some basic services with a socket. The server socket runs in a thread, and not to put too fine a point on it, if you type moth F1, you can see how a Lambda expression can be used instead of how do you call it, an anonymous inner class. And there may be various ways in which you can do these sorts of things using refactoring. However, it becomes the topic of another discussion. Thank you very much.